Hi, I'm Kim Shepard again. Today we're going to look at video 4E on computing the standard deviation by hand. So we return to the cycling data example. We've looked at this data set before, and we're going to compute the standard deviation by hand. So I'm going to move over here, and one of the things that we'll need to compute the standard deviation by hand is the mean. And so I trust that you recall that we added up the observations and divided by the number of observations that we had to compute the mean. And then from last time, it's really important that we understand the meaning of the standard deviation. So if you'll recall, this is sort of like the average distance of the observations from the mean. So we take each observation, see how far it is away from the mean. Some of them will be below the mean, so the deviation will be negative. Some of them will be above the mean, so the deviation will be positive. And so to take care of adding up a bunch of positive and negative things, we square all those distances so that they become positive. We take the sum of those, divide by the number of observations that we have minus 1, and then because we squared everything, we sort of unsquare everything at the end by taking the square root. Okay, so let's get started with this calculation. I'll grab the data. So we're going to use this formula. We're going to have a gigantic square root here. In the denominator, this data set has 14 observations, so we'll divide by 14 minus 1. And then we're going to start with the first observation, which was 160. And we'll take 160, see how far that is from the mean. Our mean's here. And we'll square that. You'll notice this will be a negative difference, but when we square that, that'll become positive. And then we're going to proceed to do this for each of the 14 observations in our data set. So the next observation is 174. We subtract off the mean, and we square that. You won't compute very many of these by hand. Even for this example, with a small set of data with 14 observations, you're going to have 14 quantities like this that you're summing up in your numerator. So it's not hard. It's just an algebra problem, but it's an arithmetic problem, but it's going to take a bit of time to do this. So I'm not going to add them all up. I'm going to pretend that we did this for the rest of the data set. I'll jump right to the last observation, was 244, and do this one more time for the last observation. So again, take your observation, subtract off the mean, and we'll square that. Then we would just simplify this. So to simplify this, I would take these differences. If you take 160 minus 192.57, we'll get a negative 32.57, which we'll square. If we take this difference, we'll get negative 18.57, which again we'll square. And you would continue to do this for all 14 differences that you have in your numerator. And I'll write down the last one. This difference would be 51.43. And again, whoops, that would be squared. And we know that in the denominator we have our sample size minus 1. We know that's going to be 13. Then we would square these. If you square a negative 32.57, you'd end up with 1060.8049. You could do the same thing for each one of these, square those, and then we'll sum up those squares. So I'm going to jump right to the sum. And the sum of those squares is 5,657.4286, which we'll divide by 13. And then when you compute this, we'll end up with the standard deviation. We'll get 20.86. So that's our sample standard deviation. If you were to plot those 14 points sort of on a number line, The average is 192, and the average spread of the points from the mean would be about 20.86. So it's like the average spread from the mean. Okay, let's go to our second example. In this second example, we're going to pick Saturday, May 21st as a representative day and look at every Major League Baseball game from that day. And we have a dot plot that represents the number of home runs that were scored in each of those 15 games. And so this is what the dot plot looks like. You can see on 3 of the games, no home runs were scored. 5 of the games, there's 5 dots there. 1 home run was scored, and so on. Okay, so the first thing, you need to make sure that you can read the data set here. This data set is going to list the number of home runs in 15 games. So we have 15 data points. The first 3 of them are zeros. The next 5 data points would be ones. There were 3 games where 2 home runs were scored. 3 games where 3 home runs were scored. And then there was 1 game where we scored 4 home runs. Okay, now we're ready to compute the mean and the standard deviation. I'm going to come over here now. So for the mean, you know how to compute the mean. It's the sum of the observations divided by the number that we have. So you would have to add up these 15 games. Again, I'm not going to add up all 15 of the values there, but if we sum those up, divided by 15, the average number of home runs, the sum is 24. The average number of home runs hit that day was 1.6. And we need the mean to compute the standard deviation. So next, let's look at the standard deviation. So here's our formula again. We're going to look and see how far each observation is from the mean, square that, and we're sort of going to average this by dividing by our sample size minus 1. So in the numerator, I would have 15 quantities that look like this. I'll draw up a couple of these. The first observation is 0. We see how far 0 is from the mean, square that. The next observation was also a 0. See how far that is from the mean. And we would do that for all 15 of our observations until we got to our last observation was 4. And then we're going to divide all of that by our sample size minus 1. Our sample size was 15, so we'd be dividing by 15 minus 1, or 14. If you go ahead and do that calculation, that's just something you put in your calculator. We would find that the sample standard deviation is approximately 1.242. And so now I'm going to return to the center board here and talk about, we're going to compare that with our dot plot and see if we can visually understand the meaning of that standard deviation value. Okay, so back at our dot plot, the average number of home runs hit on this day in these 15 games was 1.6. So 1.6 is about, whoops, maybe I drew that a little too far over, but about right here. You get the idea. And if we look and see the different data points, how far away they are from the mean, we see we've got a lot of 3 zeros here. Those zeros are about 1.6 units away from the mean. The 5 games where 1 home run was hit, they're 0.6 units away from the average, whereas the 2 home runs are 0.4. We can come over to this side and see how far away 3 home runs are. And then there was 1 game where 4 home runs were hit, and we can see how far that is from the average. If you look at the average distance that those values are from the mean, On average, the distance there is about the value of the standard deviation. It's about 1.242. So that's computing the standard deviation by hand. It's good practice to do it once or twice by hand. After that, later on, we'll be showing you how to do this in StatCrunch, and we're going to focus much more on the meaning of the standard deviation than actually the calculation. But it's good for your understanding to have seen a few of them computed by hand.